March 11, 2011, at 2:53 p.m., Japan was hit with a 9.0 magnitude earthquake that led to a tsunami that destroyed the city of Kesennuma. Tsuyoshi Engineering was tasked with rebuilding the small fishing town in a way to resist a future disaster. Our plan consists of the construction of jetties to slow the tsunami velocity, channels to direct the water flow, and a 25-foot earth mound to act as an evacuation location. Bridges will serve as connection points between evacuation areas and higher elevation. Similar to the stilted homes utilized in the Gulf of Mexico, buildings will rest on columns in order to preserve their structural integrity. To provide access to the new Commerce Center, our transportation engineers strategically place roadways throughout the city.
Since our project is starting with a clean slate, the main goal of transportation is to develop an efficient network of roadways, sidewalks, and bike lanes. The roadway network is 2.4 miles comprised of 3 different sized roadways, varying from a 4-lane with 2 bike lanes to a 2-lane with 2 bike lanes. The road, bike, and sidewalk widths will be 10 feet, 5.5 feet, and 5 feet respectively. These dimensions allow for higher capacity than was accustomed in Kesennuma and will make travel more comfortable and efficient. The network of 4-lane roads will serve Kesennuma as a highway and evacuation route in case of another tsunami. A ramp will be constructed to bring people onto the mound's lower and upper tier, which serves as an evacuation zone and connects via 2 box girder bridges to naturally elevated locations in Kesennuma.
Our typical building shown is designed on 9-foot stilted columns to ensure safety from the rising tsunami conditions. Reinforced concrete was utilized to withstand the calculated dead, live, hydraulic, and seismic loading cases, with the exception of the wood frame roof and staircase. The Japanese-style roofing is used to keep the Kesennuma culture along with the long glass windows, which will also provide the residents with a beautiful view of the Kesennuma Bayfront area. Our typical bridge is a 150-foot simple-span reinforced concrete box girder bridge. The bridge abutments are designed to withstand both longitudinal and latitudinal seismic forces. This bridge will be used as a connection point between the evacuation areas and safe grounds.
For the geotechnical design, we used retaining walls and deep foundation to support our buildings and bridges. 3 different types of retaining walls were designed. A 25-foot wall will be installed beneath our bridges. A 9-foot and 16-foot wall will distinguish the levels on our evacuation mounds and their respective elevations. Supporting for the building columns and retaining walls are 9-foot square pile caps with 3-foot diameter pile attached. The length of the piles for the 25-foot wall are 85 feet, 76 feet for the 9-foot wall, and 65 feet for the 16-foot retaining walls.
The total inundation area within Kesennuma was roughly 70 acres with a ranging wave height of 3 to 26 feet. The calculated water velocity was 43.6 feet per second and an estimated flow rate of 4 million CFS. To mitigate this extreme flow, a 1,400-foot jetty has been designed to act as a broad-crested weir to significantly slow the water. Shown here is a typical cross-section for the jetty head. The jetty stands 98 feet from the ocean floor and is constructed of a precast concrete core and 10 to 25-ton boulders. 2 78-foot channels will direct the remaining water into designated flood zones. The third 150-foot natural channel will direct the water back out to sea.
There are many construction challenges facing Tsuyoshi Engineering. The greatest challenge is the large amount of earthwork that will be performed. More than 800,000 cubic yards of fill will be shipped to the port on a large barge. This fill will be loaded onto a Cat 793C by a Cat 994 wheel loader and hauled in to create the raised mounds. Because the span of the concrete box girder bridge is relatively small, we will be able to utilize the cast-in-place method. The soffit and stems will be poured in one pass by a bit well. Once the substructure is cured, the deck will be poured in the same manner. At the mouth of the bay, about 1 million cubic yards of rock needs to be formed into a jetty. The earthwork projects will occur simultaneously, while the construction of the bridge will be delayed until the mounds are complete. The project is estimated to take 2 years to complete at a preliminary cost estimate of $100 million.